Now let's understand this clearly. We have two ways to calculate dA. Either you use the entire length, which is b, times dy, you can get a dA, or you use the entire width, which is h times dx, that will also give you dA. Now, in finding the mass moment of inertia along the x-axis, which one should we use? Now, we cannot use the strip, which is with a unit thickness, dx. The reason we cannot use this one is if you choose this one, the strip has every unit area here has a different distance with respect to x. So if you choose this to be the unit area, and you will not be able to determine or select the value of r in this integral. On the other hand, if you choose dy times b as the dA, now along this strip with the thickness of dy, the distance from the center of this dy to the x-axis is all constant. Therefore, if you choose this horizontal strip as opposed to the vertical strip, you will know which value of r to use. Therefore, we will have to use the strip always in parallel to the axis of consideration. And that's why we have to use b times dy here as a dA, as opposed to h times dx as a dA here. Now, once we figure this out, everything else is just a mathematics. So we plug in the y here because in finding the distance from the dy to the x-axis, which is from the center of dy to the x-axis, and that is on the y-axis. Therefore, this value r here becomes y. And you replace r squared with y squared, replace r dm with rho t times dA, and dA is just b times dy. And here, assuming that mass density is constant, and the thickness t is also constant, so we can take these two out. And not to forget about this value b here. From geometry, we also know that this value b is also constant, so you can also take this b out. Therefore, the entire integral becomes only rho times t times b. Now, we still have to pay attention to lower bound and upper bound. Now, the whole thing is integrating along the y-axis and perpendicular to x. So we have to ask the question that along the y-axis, what will be the starting point for the value of y, and what will be the ending point for the value of y, which will be lower bound and upper bound. The lower bound of y, which will be on the x-axis, corresponds to 0. And the maximum value of y from geometry is just going to be h. So this ix becomes rho times t times b times the integral from 0 to regular h times y squared dy. And mathematically will give us just 1/3 times rho times b times h cubed. And in finding the mass moment of inertia, it is customary to represent the value in terms of total mass. In this case, the total mass of this rectangular thin plate is simply just the volume times the density. And the volume of this thin plate is just b times h times t. Therefore, the mass, total mass, becomes mass density rho times b times h times t. Therefore, in the final expression of ix, you can just take the rho b h out and then rewrite this ix to be 1/3 of total mass times h squared. Now, what about the mass moment of inertia with respect to the y-axis? In this case, we cannot use the horizontal strip. We have to use the vertical strip for the same reason that we talk about when we calculate ix. So in this case, in calculating the iy, you have to use a vertical strip. But this vertical strip is actually the parallel strip with respect to the y-axis. And once you replace this dA as h times dx in this expression, again, the rest is just mathematics, and that becomes 1/3 of total mass times b squared. Now let's look at these two results. When we find the mass moment of inertia with respect to the x-axis, you will notice that it is a function of total mass times one dimension squared. And this dimension is the perpendicular dimension to the axis of consideration. If you look at the value of Iy, it's exactly the same case. Iy equals to the 1/3 of total mass times the dimension perpendicular to the y-axis. And this tells us one thing, that when we consider any objects for finding the mass moment of inertia with respect to an axis, it is always the dimension perpendicular to the axis of rotation that matters in determining the final values of mass moment of inertia. Let's consider the third case. Now, we want to consider not a rectangular plate, but it's a triangular plate. So here the mass is not that difficult as long as you figure out how to calculate the unit mass in terms of unit volume. And in all these examples we considered in dynamics, we're going to assume that density is always going to be constant. For civil engineers, you have to know that that's not always true. For mechanical engineers, that's probably true unless you consider a complicated engine system which is comprised of different materials. And in that case, you cannot assume the mass density is always constant. For civil engineers, unless we are dealing with steel structures, otherwise the mass density will always not be a constant. So in the case of a triangular plate with constant thickness T, how do we find the mass moment of inertia? So the same approach. Let's consider the Ix here. Ix is written as the integral of r squared times dm. Now the question is, what will be the r? Like the second example we deal with here, this r here must be the dimension perpendicular to the axis of rotation, which is the axis we use to calculate the mass moment of inertia. So when finding Ix, you look for the dimensions or the variables perpendicular to x, therefore r will have to become y. Now dm again becomes rho times dv, so t is the thickness, and the next thing you have to choose is dA. Therefore we have to use x times dy as dA. In this case, because this dy strip is the parallel strip with respect to the axis. Now similarly, when finding the mass moment of inertia along the y-axis, you have to choose the parallel strip, which is h times dx. So here Ix becomes the integral from 0 to h, as because the lower value for the y will be from 0 and the maximum value of y is going to be h. So in here we have two variables, we have x and dy, so we have to figure out that what is the relationship between x and y. And this can be determined by the linear equation, which is the equation of this slope. And on this equation we will know that the general form for the linear equation can be written as y equals to ax times x plus b. Now we have two unknowns a and b to determine, and we also have two conditions. So let's determine these two constants a and b. Look at this relationship here. The two conditions when x is... Now we have two conditions for two unknowns, and that means the value of a and b can be found. So from here we found the value of b is h, and the value of a is negative h over b. We substitute these two values back into this linear equation, and we're going to have the expression of y as a function of x to become y equals negative h over b times x plus h. Or inversely, you can also write the expression of x in terms of y just by rearranging the terms. And I'm pretty sure that you know how to do that. So once we know these two expressions, one is y in terms of x and the other is x in terms of y, we can use them for finding ix and iy. In this expression, because we use dy, so you want to find out what is the expression of x in terms of y. Therefore, we will not use this expression in finding ix, but rather we're going to use this expression in finding ix. Therefore, replace x with this expression, which is written here, and here we know that the b and h are both constants. Just carry out this integral, and the result becomes 1/12 times rho times b times h cubed. Now the total mass of this triangular plane is determined here. That equals to mass density rho times the thickness t times the area, which is b times h over 2. Now you will take this part out of this ix, so the ix can be written as 1/6 of total mass times h squared. And similarly, in finding iy, the formulation will give us this expression, which includes y times dx. Now in this case, you know that your base is x, you cannot have y in this integral, you had to find a way to replace y with x. Therefore, we will need to use this expression, which is y of x. And we replace y by this expression here, plug that into this integral, and carry out the integral, and the result becomes 1/12 of rho times b cubed times h. If you express iy in terms of total mass, and that can be written as 1/6 of total mass times b squared. Now if we compare these results, it is not surprising to see that they are awfully similar. The value of ix for a triangular plane is 1/6 of m times h squared. And if you look at the ix for a rectangular plate, it is actually 1/3 of m times h squared, which means that the mass moment of inertia of a triangular plane configured this way is actually half of the mass moment of inertia of a rectangular plane. And similarly, for iy, the mass moment of inertia of a triangular plane is 1/6 of total mass times b squared, which is 1/2 of the value for a rectangular plate. And if you also look at these coefficients, for ix, the dimension perpendicular to x, which is h, is more crucial in determining the value of mass moment of inertia on the x-axis. For y, the perpendicular dimension is b. And we also have the same result for the iy of a triangular plate. Now what if we just change the orientation of a triangular plate? How would that affect the value of mass moment of inertia for both x and y axis? Now, let's try to do that. First of all, formulate the unit mass dm to be the product of rho times t times dA. And of course, we know eventually we're going to calculate the mass moment of inertia in terms of total mass. So it is convenient to determine the expression of total mass at the beginning, which in this case is again 1/2 of rho times t times b times h. To find ix, we will have to write down the expression in terms of r squared times dm, and dm is basically rho times dv. So here, once again, we arrive this expression which regards x times dy. So here, as we discussed before, we have to choose the strip in parallel to the axis of rotation. In this case is x, so you have to choose the horizontal strip with the thickness of dy. And that means the length of the strip is actually x, but this x is not the x that we use from here to here, but it's x from here to here. So what does that mean?